Okay, here's the problem we want to do. I want to show if I have this relationship between A, B, and R, that the GCD of A and B is the same as the GCD of B and R. So what I claim is that some number divides A and B if and only if it divides B and R. So if this holds, then A and B and the set B and R have exactly the same set of common divisors. Thus, in particular, they're going to have the greatest common divisor. Thus, the GCD of A and B will equal the GCD of B and R. Okay. All right, so first let's make the assumption that D divides A and D divides B. Then I need to show it divides both B and R. Well, we already have, by assumption, that D divides B. Now, note that D divides A implies that A equals some integer, let's call it A prime, times D, and D divides B implies that B is some B prime times D integers. All right. Then solving our expression up here for R. R is A minus QB, and that is A prime D minus Q B prime D. I can factor out the D. So that tells me that D is a factor of R. So D defines R. So we now have, under the assumption that A divides B and A divides R, D divides A and D divides R, I have that D divides B and D divides R. So I've proved the implication up here in this direction. So now let's assume that D divides B and D divides R. And this time I want that D divides B and D divides A. Well, it's basically the same idea. This assumption here tells me that B is B prime D for some integer here, and D divides R is that R is some integer R prime times D, B prime and R prime integers. And so A is going to be QB plus R, again expressing that in terms of what we've just assumed, D plus R prime D. I can factor out the D, QB prime plus R prime D, and so that says that D is a factor of A. Thus, D divides A. So under this assumption, I've already had that it divides B. I have that D divides B and D divides A. And so now we're done with the whole mess.